Stapler, noun. A machine for fastening together sheets of paper or the like with wire staples. A stapler is definitely one of the most basic and needed office supplies. It comes in a variety of colors and sizes nowadays. But how did this handy tool came to be? The evolution of stapler. The very first stapler is thought to have belonged to King Louis XV of France. The large-sized handmade staples were imprinted with royal insignia and were used to fasten together court documents. In 1868, Charles Gould received a British patent for a wire stitcher which could be easily used to bind magazines. Gould's invention used an uncut wire with pointed ends that are forced through the paper and folded down. This was a direct predecessor of the modern stapler. Henry Hale filed a patent titled Improvement in Devices for Inserting Metallic Staples, which was the first machine that both inserted the staple and kept it in one motion. The earlier devices were large, chunky, and impractical. In 1879, George McGill produced the first commercially successful stapler. The staples had to be loaded one at a time. This machine featured an anvil that bent the ends of the staple back on themselves as it was inserted. The fixed anvil can still be seen on modern staples today. In the early 1900s, several devices were developed that punched and folded papers to attach them to each other without a metallic clip. The clipless stand machine, which was famous then, cut a tongue in the paper that it folded back and tucked in. Improvements to the basic designs were made to enable multiple staples to be loaded at once, in the form of strips. Finally, in 1930s, companies manufactured strips of staples that were glued together in the herringbone series, alongside staples that swung open, allowing easy loading. Staples have also found a use in surgery as a replacement for sutures. Surgical staples are pre-shaped into M. This is how the stapler has evolved over the years. Parts of a stapler. Pusher. Springs. Handle. Hammer. Pin. Carrier or magazine. Anvil. Crimp area.
The base. The base of the stapler should have the strongest plate material so that it will not deform when force is applied. It is usually made of plastic because plastic has these desirable properties of being lightweight and tough. Tough enough to resist failure due to common human mishandling. In one of the near end of the base you can locate the anvil. Anvil is a separate piece attached to the base where papers to be stapled are being held. In our model, it is made of ordinary coated steel, and through time, you can observe that there are rust that have accumulated already in the crimp area. The crimp area is the area where the staples make contact and deform its legs in the anvil. One of the possible reasons why rust developed in this area, considering that it is coated, is due to how staples deform its legs. When you try to staple, you can observe that the staple wire scrapes off the area it touches. So through numerous stapling, the coating might have wear off, causing the material or the steel to be exposed to the atmosphere and oxidized. Moreover, fatigue can also be the cause of the corrosion, and it is recommended to use stainless steel rather than ordinary steel to avoid rusting, which can be hazardous to the user's health. And of course, it can stain the important papers or documents you are stapling.
Now, since you have learned the first major component of the stapler, which is the base, let's now have a discussion on the internal parts of the stapler, which are the carrier, hammer, pusher, staples, springs, pin, and handle. So, what is a carrier? A carrier, or commonly referred to as magazine, is the one which is responsible for connecting the pusher and the staples together, and also holding the staple wires. The next one is the hammer. Hammer's main function in the stapler is to push the staples out of the magazine through the paper and onto the anvil, which crimps out the staple, completing the process of stapling. Pusher. From the word itself, pusher pushes the staples in place so that the hammer can continuously punch them through the hole. The next part of the stapler is like the bullets of a gun. This part is called the staples. Staple is a short piece of wire bent so as to bind together papers, sections of a book, or the like by driving the ends through the sheets and clinching them on the other side. Springs. Springs give the driving force to the pusher and keep the handle and the magazine in proper places, making the hammer retract every after stapling. Pins. Pins connect the anvil, carrier, and the base. Handle. Handle provides grip together with the base.
Manufacturing processes.
Creating the plastic moldings. Plastic parts of the stapler are made by injection molding, in which a liquefied plastic is injected to a die. The liquid flows into the open void and then cooled. As the die cools, the plastic solidifies and takes the shape of the die. The die is opened and the part is removed. Making the pin. The pin is a little more than a piece of bar stock, cut off to a certain length, either with a saw or a machining center. Because the pin is used as a hinge point for the top and bottom half of the stapler, it is usually made from a strong, heat-treatable metal. It should have a smooth surface for a smooth hinging operation. Painting, as required to prevent rust or for cosmetic reasons, some of the components are painted. The parts are hung on a small rack, set on a conveyor and passed by a spray nozzle. Some automatic painting operations employ electrostatic spraying, wherein parts and paint are electronically charged. The paint and the parts are given opposite charges. For instance, the paint will be given a negative charge while the part would be given a positive charge. Because of opposite electrical charges attract each other, electrostatic painting ensures that every possible space on the part would be evenly painted. This method also eliminates wasted paint or overspray. Forming the springs. The coil spring is made from metal that has the ability to withstand a constant pressure and release and still maintain its shape. Coil springs such as the follow spring are wound around rods and heat treated. The coil spring material is wound around an appropriately sized rod and then heat treated to produce changes in the metal's characteristics. Changes that give the metal its elasticity. The heat-treated coil can be pulled apart and pressed together with reason and still return to its original wound-up condition. A good example of coil spring is the follow spring, which connects the case to the follow block, the metal piece in the magazine that holds the staples forward one end of the magazine. Forming of metal parts. Most of the metal components of the stapler are formed by a metal sheet working called stamping. Stamping are typically made of flat sheet metal material of varying thicknesses that are sandwiched between a punch and a die. When the punch pushes on the material, it shears a piece of material out of the sheet.